Friends, very good morning to everyone. We were dealing with photochemical reaction. Based on the quantum efficiency and the quantum yield, what it gives, the photochemical reactions are classified into three categories. The one in which it is having a small integer, psi is a small integer like 1 and 2, and psi is less than 1, and psi is extremely high, and few of the reactions comes under this category, and I have shown over here in this slide. Let us discuss few of them. Decomposition of hydrogen iodide in the presence of light. As we know, photochemical reaction occurs in two steps. The first step is the primary reaction, where the activation of the molecule takes place. One molecule of hydrogen iodide absorbs the photons and it dissociates into one hydrogen and one iodine radical. Hydrogen iodide, it absorbs Hv and it gives rise to hydrogen and iodine radical, or it is in the hydrogen and iodine are in the excited state. This excited hydrogen and iodine, they further react in the secondary reaction. The activated hydrogen combines with the hydrogen iodide, and one electron from this hydrogen and one electron from this hydrogen, they combine together to give rise to hydrogen, and as one electron has been taken away by this hydrogen, this one electron remains with iodine, and this gives rise to iodine radical. Then the iodine radical which is formed again reacts with iodine radical which is formed before and gives rise to iodine. Hydrogen iodide gives rise to hydrogen and iodine. The overall reaction is that two molecules of hydrogen iodide reacts in the presence of the light to give rise to hydrogen and iodine. Here 2 is the psi. Quantum yield is 2 by 1. Two molecules of hydrogen iodide reacts by absorbing one quanta of light. That's why 2 by 1 is equal to 2. Similarly, hydrogen bromide also dissociate to give hydrogen and bromine. These are the reactions in which the psi has a small integer like 1, 2, 3 and so on. Sometimes the yield will be good, sometimes the yield will be less. In some reactions, the yield will be very high, in some reactions, the yield will be low. What are all the factors that affects this quantum yield? The excited molecule may get deactivated before it forms the product. The first step of the reaction, as we have seen, it is the excitation of the molecule by the absorption of the quanta of light. And this activated molecule further goes for secondary reactions. If it gets deactivated, there is no secondary reaction, and that's why the product yield gets reduced. Another reason for low quantum yield is due to the fact that the excited molecule can lose that energy by collision with non-excited molecule. Instead of going ahead, it loses that energy. It is something like the student gets activated when he hears to the class from his teacher, and by the time he come home, others will come into picture from movies to YouTube to whatnot. and there when his concentration diverges and it gets view is in excited state gets de-excited, then the quantum of yield decreases, like its efficiency of the student decreases. The molecules which are excited may not have sufficient energy for further reaction. The intensity of energy, if it is not sufficient, then also the quantum yield decreases. And the excited molecules recombine and it gives rise to the lesser yield. These are the few factors which affects the quantum yield in the photochemical reaction. That's why psi quantum yield or quantum efficiency is a small integer. Let us look into another reaction where the quantum yield is very high, that is formation of HCl. The primary reaction involves the chlorine. It absorbs the light of a particular wavelength and gives rise to homolytic cleavage of the chlorine molecule to give rise to chlorine radical. Two chlorine radicals are formed. The chlorine radical which is formed combines with hydrogen, which has one electron less, and the hydrogen is formed, molecule is formed by two atoms of hydrogen. The homolytic cleavage occurs in the hydrogen. The hydrogen along with its electron combines with the chlorine electrons to give rise to HCl and giving rise to hydrogen free radical. The hydrogen free radical which is formed again react with the chlorine to give rise to HCl and gives rise to chlorine radical. The chlorine radical which is formed reacts with hydrogen to give hydrogen radical. Hydrogen radical reacts with chlorine to give rise to chlorine radical, and the process continues, and this is chain propagation. The propagation of the reaction takes place. When all the hydrogen gets completed, then the chlorine do not have any option. The two chlorine radical combines together to give rise to chlorine molecule and then the reaction gets terminated. This is chain termination. Here the chain reaction terminates when the chlorine atoms recombines at the walls of the vessel by losing their excess energy. The quantum yield here is in the range of 10.4, 10 to the power of 4 to the 10 to the power of 6. The high quantum yield is because of the fact that absorption of radiation in the first step gives rise to free radical which gives the initiation for the chain reaction. The intermediates which are formed, they can act as a catalyst, and if exothermic reactions are exothermic, the heat energy that is produced by this exothermic reaction can also activate other molecules and it also adds up to the rate of the reaction and also to the quantum of the reaction. The active molecules can collide with each other and again gets activated further. And these are all the factors which gives rise to the higher quantum yield. Ozonization of oxygen. The oxygen molecule absorbs the oxygen molecule absorbs ultraviolet rays from the sunlight and it gives rise to oxygen atoms. This occurs at the utilizing the UV light of the wavelength of 240 nanometer. Then The oxygen atom which is formed combines immediately with the oxygen molecule to give rise to ozone. This is the secondary reaction. The reverse is equally true. UV light of 240 to 315 nanometer disrupt the bond of ozone to give rise to oxygen and oxygen atom. And the peak ozone destruction occurs at 254 nanometer wavelength of light. This is also an example of photochemical reaction. Let us look into the other types of photochemical reactions in the coming presentation. Till then, have a nice day. Thank you.